Hello, this is Mrs. Wong here. In this video, we'll be going through the MYE question 5 from paper 2. Okay, so for question 5, it says that a cylinder of height x cm and base area r cm is cut out from a solid sphere of radius 4 cm. Part A wants us to express r squared in terms of x or otherwise to show that the volume of the cylinder is given by this expression here. Okay, so for this, we actually have a few ways to do. Our solid sphere has radius 4 cm. Okay, so I'm going to indicate that with a center. Okay, and this is also the radius, so this is 4. And I actually have x divided by 2 here in a right angled triangle. Okay, so I can actually form a relationship. I'm going to write my answer here. Okay, so using Pythagoras theorem, I can actually link r and x together. Okay, so I have actually expressed r squared in terms of x by using Pythagoras theorem. Okay. Then now I need to write down the expression for the volume of the cylinder. So the formula for volume of cylinder is actually pi r squared height. Okay, the height of the cylinder here is actually x. Okay, the radius is r. So if I were to put it in, I will get pi r squared x. Okay, and I actually have r squared from Pythagoras theorem. So I'm going to substitute that in to get 16 minus x squared over 4 times x. Okay, so if I were to actually expand this, I will actually get the expression that the question wants. Okay, so volume of cylinder V is actually pi times 16x minus x cubed over 4. This would be for part A. Let us now go on to the next part. For 5b, we actually need to complete the table of values. Okay, when x is equals to 5, we need to substitute the value of x into the equation given. Okay, and that actually gives us 49. Okay, for part C, we need to draw the graph for x is from 0 to 8. Okay, so if we were to plot the points, we see the curve in blue. That is actually the graph that they want us to draw. Okay, so we label the curve. That is for part C. We'll now go on to the next part. Okay, part D wants us to draw a tangent to find the gradient of the graph when x is 5.6. Okay, so we will go back to our graph and then we will locate x is 5.6 and we will draw the tangent of the curve there. Okay, so the red line here, okay, is actually the tangent. Okay, I've put a red cross to show where x is 5.6 and the tangent that is drawn, okay, is in red. Then we will use this to find the gradient of the curve at x equals to 5.6. Okay, we can do so by taking two convenient points. Okay, so you pick 2 points that are convenient for you on the graph. With the 2 points, we will then calculate the gradient of the graph when x is 5.6. Okay, so for this, the answer, we actually accept values between -8 all the way to -7. Let's go on to part E. part E wants us to use our graph to find the greatest value of V. Okay, so we actually want the greatest value of V. Okay, now if you go back to our part A, okay, the value of V is actually pi times of 16x minus x cubed over 4. Okay, but the graph that we have drawn, okay, the graph that we have drawn is actually y equals to 16x minus x cubed over 4. Okay, so from our graph, we can only get the greatest value of y. Then we have to multiply by pi for us to get the greatest value of v. Okay, so let's go look for the largest value of y. So if we were to look at our graph, okay, the largest value of y, okay, so it will be somewhere around here. Okay, is actually 49 point something. Okay, so you use your value of your graph that you have drawn, okay, to get the highest value. Okay, so let's say you get 49, then I have to find the largest value of v, which is 49 pi. Okay, so my largest value, okay, if yours is 49, you just sub it in, okay, and then you will get your answer. Okay, so we actually do accept a range of values for v here, depending on the range of value of v. Okay, but of course for y, okay, the range of value of y be something between 59 to 50. Okay, so when we substitute in this value here, okay, we should get between 154, okay, to 157. Okay, let's go on to the next part. Okay, the next part wants us to draw the line of y equals to 50 minus 5x on the same axis. So if we were to go back to the graph, okay, the line in green here, okay, is actually y equals to 50 minus 5x. Okay, so if you're not sure how to draw this line, you can actually plot out a table. Okay, sub in some values of x. Okay, you can choose convenient value of x between 0 to 8, then get the corresponding values of y. Okay, and then plot some of the points to actually draw this straight line here. Okay, the next part wants us to write down the x coordinates of the point where the line intersects the curve. So we have to use the graph to get the points of intersection, okay, the x coordinates. Okay, so we actually do have 2 points of intersection. Okay, so you read off the x coordinate and we will get these two values. Okay, so a range of values are also accepted. Let's go on to part 3. Okay, these values of x are the solutions of the equation, and we want to find the values of a and b. So for this last part, what we have to do, since the values of x are the solutions of this equation, okay, so what we have from part 2, okay, is actually the points of intersection of the line and the curve. So the line is actually 16x minus x cubed over 4, and the line of the equation, okay, is 50 minus 5x. So basically we are equating the two y's together. Okay, and then we will do some simplification first. Okay, so we multiply everything by 4. Okay, to get rid of the fraction. Okay, then we rearrange to actually get this. So if you were to compare it with x cubed plus ax plus b equals to 0, okay, we will actually get the values of a as negative 48 and b as 200. Okay, so for this, because we actually have the line and the curve intersecting, so we equate the two y's together, and then we simplify, okay, to get the equation. So this is for question number 5.